so today we're going to be learning about square roots. We already talked about what we know as far as square roots. We watched a video on Mashup Math, which you can find on our Google Classroom. We'll put the link, so if you want to watch it again, so that you can make sure you understand what square roots are. Alright, so let's think about square roots here. So square roots, when you square a number, you multiply it by itself. So what does 5 squared mean? What does 5 squared mean, Lexi? Okay, it means 5 times 5, which is then equal to 25. Very good. Alright, 5 times 5. So the square root, so the square of 5, what is the square of 5? 25. Alright, so the square of 5 is 25. You can indicate squaring by using that exponent of 2, and we did that a lot in the last section of the chapter. What is the square of 7? What is the square of 7, Eddie?
49.
Very good, 49. What is 9 squared, Afi? 81. Alright, we are now going to distribute a perfect squares reference sheet. We're going to take a minute so that we can staple it into our notebook, because this part of the chapter we expect you to know, so you're not going to be using your calculator. Yeah. So we did say that we won't necessarily be using the calculators all the time, but we do want to show you where on the calculator you could do square root. So first, if you want to undo squaring, if you want to get rid of a number being squared, like for instance, if you want to get rid of 7 squared, you have to do the opposite of squaring. Well, the opposite of squaring is to take the square root. If we want to undo something that's squared, we want to take the square root. So what's 7 squared? 49. So if we want to get rid of it being squared, we can do the square root of 49 and we get 7. This symbol right here, someone had known that before, it is called the radical sign. If you will use your calculator, everyone please take out your calculator. In order to find the square root symbol, you have to press the second button. Alright, you need to press the second button, and then you need to press the x squared button. Alright, so you can try it now. If you wanted to check and see what the square root of 100 is, you would press the second key, then you would press the x squared key. So on your screen, you would get the radical sign, and then you would type in 100. What is the square root of 100? Nice job, it's 10. And that's how you would use your calculator. Next, here's some example of perfect squares. They talked about this in the video. 49, the square root of 49 is 7. So if you were to make a square, each side length would be 7, and it's a perfect square. The square root of 169 is 13, which means each side of this perfect square would be 13. But then they have a big X on 24, because the square root of 24 is not perfect, meaning I can't use a whole number for the side length of the square. So that's the difference between a perfect square and a non-perfect square. The chart we gave you is all the perfect squares. So raise your hand if you know the square root of 4. You can use your chart if you need help. Vanessa. 2. Oh, that's not locked in place. There we go. Oh, the answers are underneath it. Alright, so I'm not going to move that. So the square root of 4 is 2. Square root of 49, Angelo? 7. Square root of 64? 8. Square root of 1? 1. Square root of 0? 0, because 0 times 0 is 0. Let's see, did we get them all right? Yes, we did. Nice job. Alright, please write this in your notes. So this is the first thing you've had to write today. So you are going to write the square root of negative 25. So we have talked about this. we talked about the square root of 25. What is the square root of 25? I see. 5. Okay? Now we're looking at a problem where it says the square root of negative 25. So can we find the square root of negative 25? Angela? No? Why not? Because it's a negative, so what if I did negative 5 times negative 5? It would be 25. Oh, it's positive, right? Yeah. Well, what if I do positive 5 times positive 5? That's still not going to be negative either, right?
Yeah, so positive is a cube.
So you can't do it. So this is an example of no solution. So there is no solution. You cannot have a negative number under the radical sign and take the square root of it. You can't do it because of our integer rule. Because any number, and you're writing this down, please, because any number times itself will always be a positive number. So negative 5 times negative 5 is always positive. Positive 5 times positive 5 is always 25. So you can never, there's always no solution, is what you write as your answer, if there is a negative under the radical sign. So, we're going to talk about something called a battery symbol. Your book is going to use this a lot. You're going to see a problem like this, so please write this down. It's going to have like a plus minus outside of it, and then a square root of 100. We kind of refer to that as the battery symbol. Because the square root of 100 actually has two answers, not just one. It could be positive 10, or it could be negative 10. Because negative 10 times negative 10 is positive 100. Alright, so this is a lot of writing, having to write it out like this. The short way to write a problem like this, so maybe you have the square root of 64. They're going to ask what are all the possible answers for the square root of 64. You can just write the battery symbol and then 8. Because the square root of 64 can either be positive 8 or negative 8. Okay, so you will see that in a lot of the problems that we do. You'll see the little battery symbol. What about 5 times 5? Yeah, so like anytime you see a square root, so technically every time I was writing the square root of 25, I should have been writing that. Because it can be positive or negative. Okay, so putting that battery symbol in front of your answer is necessary. Because there actually are two answers for every square root problem. Alright, the way that you read this, so you're going to want to write this down. When you have a problem like this, the way you read it is the opposite of the square root of 25. Because that's what we're doing. It's different when the negative's on the outside, because we're doing the opposite of the square root of 25. So what's the square root of 25? 5. Now this is a case where you wouldn't put plus or minus. Because clearly they're telling you to do the opposite of the square root of 25. So what's the opposite of 5? Negative 5. So that would be, that's our next one. So our answer would be negative 5. Who can tell me how I would say this? How would I say that? How would I say that? Afi? The opposite of 100. Good. And the answer is, Lucas? Negative 10. And the answer is negative 10. So it is okay for a negative to be on the outside of the radical sign. That is fine. It is not okay for it to be inside the radical sign. What? Next. Did you guys write this down?
Yeah.
I'm writing. Is it bold? Alright, so let's try some of these. Square root of 64.
8.
8 plus or minus 8 to be exact. Make sure you put the battery sign. These 4 examples should go in your notes. The next one, square root of 225, 15 plus or minus 15. Okay, it could be positive or minus 15. Next, I have the square root of 1.21. Lucas?
No solution. Right? No.
There is a solution. There is a solution, Julius.
14.11.
You're on the right track, but your decimal point's in the wrong spot. Ariana? 1.1. Yes, it is. All right, so plus or minus, and it's 1.1. Think back to 6th grade math where they didn't let you have a calculator. Okay? So 1 times 1 is 1. 1 times 1 is 1. Hold my spot. 1, 1. 2 places. There's 2 spots after the decimal. So my final answer, that's where my decimal goes. Okay? So that's why the decimal point, there has to be one number after it. How about this one? The square root of 1.44, Sean? 1.2. Very good. 1.2. 1.2. And you're going to find a pattern with these probably after tonight's homework. So that's one question we will definitely be asking tomorrow, is do you see some sort of pattern with the decimal? All right, so we want you to look for that when you're doing your homework tonight. All right, so same thing. It's just going to increase the level of difficulty because this is 8th grade math. So how would we say this? How would we say that? How would I say it, Michael? The opposite of 25 over 36. So because it's the opposite of 25 over 36, I know my final answer is going to be negative. Now just look at the numerator. What's the square root of 25? What's the square root of 36? And you're done.
That's it?
That's it. So what looked hard and confusing because it was a fraction, oh my, it's actually very simple because we just take the square root of the numerator, square root of the denominator. Next. I want to do the opposite of 16 over 81. No. It's 8. It's not 8. It's not 8, so we're thinking square root of 16.
4 over 9.
4 over 9. Negative.
Negative.
And it's negative 4 over 9. Good job. Make sure you have the negative sign because that was outside the radical sign. I think there's one more. No, there's not. All right, let's try this on our own. I believe this is page 72 in your book, A through D. Okay. So the first one, we have the square root of 9 over 16. 9 over 16 is going to be 3/4. Okay, 3/4. It could be positive, negative, so I'm missing the battery symbol, but you can make sure you add that in. For B, the square root of 0.81 is positive 0.9 or negative 0.9. I know, wait, I didn't trick you yet. All right, C, the opposite of the square root of 49 is negative 7. And I need a drum roll. Can I have a drum roll, please? I tricked almost every person on this. Can we take a square root of a negative number? There is no solution. Now we're going to take this to the next level and we're going to end up solving equations involving squares. So here I have solve a squared equals 121. So I have a squared equals 121. All right, how would we solve this, Michael?
Alright, so the opposite, and it's like common math. 11 times 11 is 121.
All right, so it's common math and it's the opposite because we're going to take the inverse operation of squaring. So I see a squared here. Well, a squared is just a, because a squared means a times a. So a equals 11. And that's what you do. That's why we need this operation. Because when we solve equations, we need to keep them balanced. And if I want to get rid of something squared, I can take the square root of both sides and my equation is still balanced. Next, we're moving on to cube roots. Unfortunately, we do not have the cube roots on the reference sheet we gave you, but you do need to know these first 10 cube roots. So please write these in your notes. So the cube root symbol has the 3 and then the radical sign. You could think of it like a cube. If you wanted to find the volume of a cube, you have to do length times width times height. There's 3 things. Or when you cube a number, it's to the 3rd power. So the cube root of 1 is 1, because 1 times 1 times 1 equals 1. Down here, the cube root of 125 is 5, because 5 times 5 times 5 equals 125. All right, so let's do some examples. So please write this problem down. The cube root of 125. What is the cube root of 125? And that's
5.
5. Very good. Please write this example down. Next, what is the cube root of 27? 3. Good job. What's the cube root of negative 27? Negative 27. Lots of hands up. I like it. The enthusiasm. The time.
No solution.
No solution. Michael's still jumping. Michael.
Oh, there would be a solution on this one, because it'd be a negative times negative times a negative.
And what would that negative be?
Negative 3.
So it would be negative 3 times negative 3 times negative 3. It equals negative 27. So the solution, Michael is correct. There is a solution. You can have a negative under here, and the answer is negative 3. So if you're doing the cube root, you can have a negative underneath the radical sign. It is possible. Please write that example down. And then try this example. What is the cube root of negative 1,000? The cube root of negative 1,000. Nancy? Very good. Negative 10. Because negative 10 times negative 10 times negative 10 is negative 1,000. Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil. Solve the equation 8 equals s to the 3rd power to find the side length of the container. Sean? The answer is 2. Why is the answer 2? Very good, because you're going to take the cube root of both sides, and 2 times 2 times 2 equals 8, so the side is 2. Each side, the side is actually 2 feet to be exact. 2 feet for the side. All right, now you can practice on page 72 and also write down your homework. Page 74, 1 through 10, 75, 1 through 12.